Right, so I'm Craig. I'm a product guy at Google. I've been doing the cloud thing for a little bit over there. Built a product called Google Compute Engine, which is an infrastructure as a service product. And then more recently have become really fascinated with the idea of bringing some of the capabilities that were previously only available to PaaS customers, and that were really very well represented by the way that big internet companies like Google or Facebook or Twitter run their applications. And so for this conversation, I'd like to start with the assumption that OpenStack is happening, right? Like OpenStack is actively in the process of democratizing infrastructure as a service. It's making it available to everyone everywhere. And it's solving a very real problem for the enterprise customer, which is resource management, resource provisioning, and creating a set of virtual constructs that are very accessible and easy to get up and running, to access and to use, and to deploy your code into, right? So that's really the starting point. Now, when you look at what I've been working on for a little while, I kind of started there too, right? So I started by building a traditional virtual machine computing product at Google because I knew that the world needed virtual computing constructs. I knew that we needed to reach the developers where they are, and that this type 1 cloud, this infrastructure as a service cloud, was a critical staging point to do some other interesting things. But at the same time, I've been involved at Google, and we have had other cloud products. So we had Google Compute Engine, which was just something I worked on. But we also had Google App Engine, which was what I'd call a generation 1 platform as a service product, and a very successful one. And what I started really becoming fascinated by was the huge gulf that existed between Compute Engine and App Engine. The fact that at one end of the spectrum, you could provide your code and everything would just happen for you. And at the other end of the spectrum, you would have a piece of infrastructure that you could SSH into and deploy things on and run. But there was nothing in between. And I certainly saw some shortcomings in the PaaS space that were gating adoption and gating the success and gating developers' ability to really just embrace something that was going to run their code for them. So I started thinking, like, what's wrong with PaaS? Like, why are people having these experiences? And what it came down to me was really this idea that in PaaS, you encounter these things we call an experiential cliff. So you start off and you have this wonderful love affair with your platform, and it does everything for you, and it just takes care of you in this beautiful way. But eventually you get to a point where you want to do something that your platform can't do. And then it's a cliff. And then you're looking over this cliff, and you're wondering where to go from there. So on the upside, you got this effortless scaling, effortless management, ease of use. You could go from nothing to running code to internet scale very quickly. But you had to give up flexibility to do it. You had to accept a relatively closed and opinionated operating environment to do that. And that meant you had to give up things like having a lot of options around how you'd manage state. So let's say you wanted to run PostgreSQL because you wanted to do some specific sort of geo-based querying or something. You would struggle to get to a point where you could do that. So you'd have to figure out some other option. And generally that meant going back to VMs. So hey, I was in PaaS, I was having this love affair with my technology, and all of a sudden I'm back in the world of VMs. And I always saw this as kind of a leaky bucket problem. You'd have to poke holes in the bucket, and you'd have to actually start running parts of your applications in virtual machines, and you'd have to start investing in infrastructure to manage your applications in virtual machines. You'd have to build multiple discrete environments. And no one wants to do that. No one wants to manage two discrete tool chains. No one wants to be in a world where you have to train your developers with two discrete paradigms of operations. And so eventually all the water will run out of the bucket, and you're back in the VM world, right? Unless you happen to have a workload that fit perfectly in the PaaS space. And we certainly encountered a lot of that, particularly for the internet scaling scenarios. There's some workloads that work just really well in that environment. And so I started really thinking about this, what is it that PaaS brings to the world? What is it that PaaS represents? And how do we take that and extricate it and sort of tease it apart into its constituent pieces? And who's already doing this? Because this is already happening in many ways, and I'll get into that. And so the first thing that I think about with PaaS is providing this kind of deterministic and resource-efficient deployment model. So I provide it my code, it puts it into some kind of package, and then it will take it out and deploy it into as much infrastructure as I need on a very efficient basis. So the modern sort of the generation 1 PaaSes were actually pretty efficient at resource allocation. We had a lot of customers running small amounts of code very efficiently in App Engine. And the same is true of any of the other platform as a service offerings. And that's a very powerful thing. The next thing is that they offered up a natural orchestration pattern. So, hey, it would take my code and would reason about how to do an update. So, hey, I need to go from A to B. I can do that deterministically without interruption, without disruption. That's very powerful. It would monitor my application. It would manage the health of my application. These are all very good things that reduce the pressure on your operations team. And it would also offer up a set of curated application environments and a build process. So I could say, hey, here's my code, and it would provide all the other pieces I need in terms of my user land dependencies and offer it up to me in a way that was really nicely curated. And then I could just press a button, it would be built and deployed. So all great stuff, all relevant to engineers, but not necessarily sensible to tie together into a monolithic thing. And so looking back, I don't know if anyone remembers this company. They were just another PaaS platform back in the day. And like a lot of the other PaaS platforms, they had some interesting technologies. They were certainly on my radar. But they never gained that critical mass of massive adoption, right? But they did something that was really neat. They took one component of PaaS, something that they had to solve for their own customers, which was packaging and distribution, right? So they took the essence of the platform as a service packaging and distribution model, and they turned it into something else, which I think most of you've probably heard about by now, which is Docker. Docker has had quite an impact on the developer and sort of operations world out there. They've done some very impressive things. And when I look at Docker, I really think of it as being magic in three parts. I think that Solomon's put lightning in a bottle. And there's three things that they do just remarkably well and that I'm very impressed with. And I don't think, I'd certainly been thinking about containers for a long time. I didn't necessarily see Docker coming until, until they'd actually accomplished some remarkable things. And I don't think many other people could have done this, which is they recognized that the Linux syscall layer was just an incredibly stable interface between your infrastructure world and your application world, right? So the Linux syscall layer that exists in Red Hat Enterprise Linux is very like the syscall layer that exists in Ubuntu, and it's largely compatible from version to version to version. So if you take that as your starting point and say, this is how my application is going to interface with my environment, you have a very stable and ubiquitous interface that offers up legitimate portability. So I can actually take my application, develop it here in one environment, and then move it to a variety of other environments, which is very powerful. I think they recognize the value proposition of a stackable file system. So being able to take a base image, extend it, add your own code, package it up as a hermetically sealed unit, and then redeploy it out. So offered up a remarkable amount of reuse and extensibility, and really made your first few hours just wonderful because, hey, I could just go grab something. It's hermetically sealed. It's perfectly packaged. It just works. I can add my code, and now I can reseal it. I can just deploy it, and it's great. And they also did an amazing job of just creating a really clean and accessible developer experience. So Docker's done super work. And as a result of it, it's hugely successful as an open source project. It's garnered a tremendous amount of attention. And developers get some of the essence of PaaS, right? Like a few of the things that PaaS used to do, but they get it on their terms. They get it in an unopinionated fashion. They get it in an open fashion, and they can take it wherever they want to go. And that's a very powerful thing. Hermetically sealed application environments, this portability, and then an efficient resource isolation metaphor. So I don't actually think of, just for the record, I don't think of containers as being an effective security isolation domain just yet by itself. I think we'll get there as a community. I still think that you really want to use virtual machines to do tenant isolation. But containers do offer efficient resource isolation. They do let you pack a lot of stuff next to each other and use up every part of your computational resource in a very effective way. So isn't that enough? Aren't we done, right? Like Docker, woohoo, it's done, right? And it's created a really amazing first 5 hours, right? So you're getting this, like things just work. It's a profound paradigm shift. I really worry about the next 5 years, right? So now you've built the application, you've had the party, how are you going to operate it, right? Like, you need to be able to take these containers and you need to be able to map them into your OpenStack operating environment, right? So I have my computational resources. Do I do just one container per resource? Probably not. A container shouldn't be a VM. it's really more of an executable. So how do I actually map a lot of them into a VM boundary? How do I schedule them in such a way that they're using every part of my infrastructure in a remarkable way? How do I wire them into the internet? How do I attach them to my storage properties? I want to use block storage. I want to like wire it into Cinder, or I want to wire it into Swift or any of the other properties. How do I do that in an efficient fashion so it just feels natural? And then, how do I deal with operations? My engineers should be writing code. They should be really focused on solving my business problems. I really don't want them to spend an inordinate amount of time focused on some of the kind of the nitty-gritty operational components. So I need an operational framework. And you might have heard about this microservices thing. It turns out it's a really neat way to start thinking about factoring your production applications. And we really would like to make sure that as part of this transition, as this disruption, we don't just reproduce a lot of the mistakes we made previously in terms of the way that applications are architected. We have an opportunity to rethink that. And we have an opportunity to actually bring this microservice-oriented technology to market. So in Kubernetes, which is an open source technology project built by Google, and really embraced by the community. So it's not just a Google project, it's also a Red Hat project. And it's an alloy that's stronger by by the open source community that's actually helped build it. And it's something that we're very interested in, obviously, working with the OpenStack community to bring to this infrastructure as a service world. And for me, in a nutshell, Kubernetes extracts the best of platform as a service orchestration and management. And it does it as Docker has done for packaging, deployment, and the development environment. Kubernetes is doing for the operational experience. So you get orchestration and management, and it just works nicely for you. And so if you've ever had trouble with any of these kind of operational realities of making sure you have a very cleanly matched development and production environment that goes beyond just the code you're running, the set of common services you use, the tools you use to actually do the deployment, the way that you reason about scaling your application. If you want to be able to test that in development and production environment, if you want to transition your code from one environment to the other, and make sure that you have an incredibly consistent set of experiences across these environments, Kubernetes might be for you. If you think a lot about if updating your application in production makes you apprehensive and makes your blood pressure go up by like 30%, and if that keeps you awake at night, you might want to think about one of these platforms, because they really do distill out a much better way of thinking about operations by providing intelligent systems that will do it for you. If you care about efficiency, these technologies were really born of the internet companies. This is the way that Google runs, or Facebook runs, or Netflix runs. And it's let us get so much more out of our basic infrastructure, achieve several integer multiples, higher levels of efficiency. So if you actually care about the amount of infrastructure you're spending, and you want to consolidate, and you want to reduce your capital expenditure for infrastructure, these technologies will help you. And if you also care about agility, if you want to be able to start creating applications that grow with your business, where each of your business functions are sort of discretely represented through these microservices architectures, where you can easily just wire things in and make them accessible, and where your applications aren't bound together and coupled to the physical infrastructure primitives they're running on, these technologies might be for you. And so I like to kind of use analogies as a way to explain this, just to kind of help people really conceptualize what it is. And one of the analogies I'm very fond of using is this analogy around model airplanes. So I don't know if you've ever had a model airplane. I used to have one as a child. It was great. We'd do loops. We had a lot of fun. And then one day it was 10,000 pieces of balsa wood spread across a sports field, right? Because they're hard to fly. And turns out, like, if you think about it, the way that we run our applications is very similar, right? We give it to an operator, and they build the thing, they set it up, and then they try to, they run it often. It's not. Sure, they will add autonomous, subsystems to, help deal with load balancing, but often as not, those are, based on very weak heuristics. Turns out, if you think about what's happened with drones now, we've moved, to a generationally different thing, because one of the things that computers do better than people is fly these little model airplanes, right? But it's not just better at it. It's not the same thing that just flies a little bit better. It's a fundamentally different thing. By adding dynamic control systems to this little model airplane type metaphor, we've created a profoundly different piece of technology that is able to do things that you could not possibly have done with the best pilot in the world of one of those little model airplanes. Because it turns out there's some things that machines just do better than people, right? And one of those things is using autonomous control systems to achieve an intent-based objective you have. So I can tell my drone, hey, go into the corner of the room, and it will go there. Why isn't application management like that? Why aren't we relying on intelligent systems that can observe the operating properties of your application and make informed decisions using these control loops, right? So inside Google, we use this for pretty much everything. We've been using containers for around, I think, 11 years. And a lot of the work that the community's been doing is around technologies that we originally contributed to the open source community. And what it's given us is a higher level of abstraction. We're operating at the Linux syscall layer. We can actually see what's going on with our applications. We have far higher fidelity data. And as a result of that, we can do clever things with machine learning. We can watch something, and we can see, you know what? This thing's call signature has changed. There's a decent chance someone's exploited it. And I can make an informed operational decision to do that. Find one system administrator who's going to actually sit there and watch in real time what's going through on millions of systems. People can't do that. Machines can. And we need to bring this kind of capability to the world of application management so that our developers focus on solving problems that they are good at solving, and the machines themselves can solve problems that they're good at solving. And that's all about the operational piece. And so, obviously I'm here today because, we look at OpenStack and we Google are very impressed with the way that this technology's moved forwards. It's becoming ubiquitous. It's achieving far better semantic consistency across the deployment set. And I think there's a real legitimacy to the community. And what we would like to do, what Google would like to do, and how we'd like to operate is we'd like to meet OpenStack where it is, and we'd like to start bringing a lot more of these kind of cloud-native paradigms. So contribute our expertise, contribute technology to the OpenStack community to help it move forwards and get over the energy curve so that every OpenStack developer can be running cloud-native. So every OpenStack developer is benefiting from this new class of management. They're able to focus on their code rather than operations. They're able to get remarkably higher efficiencies without sacrificing the fundamental robustness and reliability of their subsystems. And we're very excited that this is already happening. The community's already rallied around this. We see Magnum adding a native Kubernetes API to OpenStack through a Python sort of head on the project. We see Murano as an easy way to get these technologies up and running. And what you'll start to see from us, over the next couple of months, as we really focus our attention on this, is hopefully far more natural integration across the OpenStack stack. So I think about things like, really working together to create this path to cloud native, and as a community addressing some of the obvious kind of cognitive gaps that exist, or like creating the obvious bridging. So for instance, Kubernetes has a really nice microservices model that makes it very natural to find, discover, and consume a piece of technology. Realistically, I know that almost every customer who's running a real deployment isn't going to have their entire application, insofar as everything it touches, packaged up into one of these kind of, whiz-bang cloud-native environments. The reality is they still have to interface with a lot of their existing work. So we need to make that integration model very natural. We should make it completely transparent, whether you're accessing something that's a cloud-native component, from outside a cluster, or from inside a cluster if you're accessing something that's running in a vertically scalable VM. We need to create a consistency of experience. We need better integration with a lot of the basic subsystems. I mean, our friends in the OpenStack community have already done a lot of work to make sure that these things work. But I think there's a lot of opportunity as we think about applications becoming far more network or storage centric to actually get deep integration with properties like Neutron. I think we should be thinking about a solution to actually bring on the metal execution to the OpenStack community. I think that VMs have a very bright and vibrant future, and they're the only way to achieve legitimate security isolation right now. But for a lot of people that don't need that, there's a very efficient story around just scheduling containers on bare metal, and we should be thinking about that as a community. And so I'm really excited about this. I thank you for your time, and if you want to sort of ask me questions, you can find me sort of drifting around this afternoon. And with that, I'll hand it off to... Thank you.